A thyristor is made of 4 alternating layers of N and P regions. To understand why the thyristor is used, let us look at the workings of a normal transistor, a BJT. When we connect a primary power source, we observe one of the junctions of the transistor is always reverse biased. To turn on the transistor, we just connect the secondary voltage supply between the emitter and the base terminal. This will turn the transistor on. However, if we remove the secondary voltage supply, the transistor will turn off as it needs a continuous secondary voltage supply. The need for a continuous base current supply causes a huge power loss, especially during high power applications. To overcome this problem, in 1950, William Shockley proposed a very interesting power switch known as a thyristor. In thyristors, unlike with transistors, no such continuous secondary supply is needed. After the triggering, even if you remove the secondary supply, the thyristor will keep on working. If a silicon structure wafer is doped with 4 alternate forms of P and N types, a thyristor is born. Here also, the formation of depletion regions occurs at the junctions. Whichever way you apply a voltage in a thyristor, there will be always at least one reverse biased junction. In the second case, there is only one reverse biased junction. Let's try to make a working thyristor from this configuration. In order to make the thyristor conduct, we have to break this depletion region. In thyristors, an efficient and popular method called gate triggering is used for this. Gate triggering is the process of the injection of electrons. For this, let's connect the secondary voltage supply to the gate and cathode terminal. This secondary supply injects a lot of electrons into the P region. As this process continues, the P region becomes overflooded with the electrons. The electrons have now become majority charge carriers in this region. In short, the P region eventually becomes an N region. This new N region will cause the depletion region to automatically diminish. As the P region has become a new N region due to the gate triggering, the 3 regions on the bottom side collectively become a big N region. Now, the structure of a thyristor looks like a PN junction diode. As we have seen earlier, when we apply a forward bias voltage supply to the PN junction diode, it starts conducting. At this stage, even if you remove the secondary voltage supply, the thyristor will keep on working, since the injected electrons in the P region have already made it into an N region. This way, in the thyristor, the secondary supply voltage is needed only for the triggering.